Whenever you hear the term limelight, most people would immediately think of the world of showbiz, specifically the bright spotlight that follows people prancing around on theatre stages. But why is it called a limelight, and how did a tool, originally designed for mapmaking, end up becoming associated with the worlds of stage and screen? Well, let's go way back to 1747. The British Army was fighting a Jacobite rebellion in the Scottish Highlands, and they needed good maps to help them fight their battles and to subjugate the clans afterwards. Existing maps weren't very accurate or very detailed. The outlines of nations were sort of accurate, but in many cases looked more like a plastic cutout of the country that sort of melted a bit. And even the maps that were accurate in how they depicted the outlines of nations, counties and towns would almost certainly lack plenty of important little details such as minor roads, pathways, rivers and buildings. The sort of stuff an army would really need to know about. So the army set up a division to produce such quality mapping using the latest techniques and technologies. Realising the benefits of having good quality maps for both military and governance purposes, the army started mapping the rest of the UK as well, starting with the coastal areas. Europe was getting politically turbulent, and there was an ever-increasing risk of invasion from France. Good maps would be vital defending off such an action. In 1791, the Army's map-making division was formally named the Ordnance Survey and was tasked with mapping the UK and its conquered lands. The Ordnance Survey that currently exists in the UK is the same organisation, albeit now manned by civilians instead of military folk. The science of map-making was pretty well understood at the time. Triangulation could be used to measure distances between three landmarks arranged in a virtual triangle, so long as you knew the distances between two of those landmarks already. A device called a theodolite, essentially a rotating telescope attached to a protractor, could be used to measure the corner angles between the landmarks, and the length of the two missing lines could be worked out. Theodolites are still an essential tool for surveying. You may have seen them in use around building sites, and also possibly in the 1984 film Breaking 2 Electric Boogaloo, where the community centre was being sized up for redevelopment, and some of the local children thought it was a camera of some sort. But anyways, most theodolites move in two dimensions, vertically and horizontally, so this allows measurement of the heights of buildings and mountains as well as ground distances to be measured, so it is quite possible to map in 3D. The problem was that getting good maps meant getting feet on the ground. It was a very resource-intensive task. Someone had to go out to all the triangulation points and take measurements. For example, taking triangulation measurements between buildings in a town is easy. You can easily see the points where you need to aim your theodolite. But what about between mountains? There needs to be a visible marker on each trig point visible from the other trig points. And this has to be really accurate. A fraction degree error in calculating the triangulation will be multiplied when you derive sub-triangulations from it. If the tops of mountains are miles apart, how can you be sure that you're aiming your theodolite at the correct peak of the mountain, especially when the mountain has a plateau top? A person will be too small to spot from a distance, and building a large visible structure to use as a landmark would just be too impractical. The problem was solved in 1824 by Major Thomas Colby and Lieutenant Thomas Drummond. They had been tasked by the Ordnance Survey with mapping the island of Ireland for military and taxation purposes. Colby was a man with an eye for detail, and he wanted to make the survey of Ireland the most accurate possible. To begin the survey, he needed to measure a baseline, a single dead straight line whose length would be known to a very high degree of accuracy. From that baseline, he could use trigonometry to triangulate distances to nearby mountain tops and landmarks. Once those distances were known, you could use these as the baselines for more triangulations, and so on until the whole country was covered. He chose an area on the banks of Lough Foyle to measure his baseline. The area was chosen as it was very flat, had few obstructions, and was close to sea level. To measure the line, Colby developed a device called the compensation bars, lengths of iron and brass bolted together through a pivot. As the two metals contracted and expanded at different rates, they would cancel each other out, and the distance between the end pivots would always be the same, no matter what the ambient temperature was. The surveyors would move the measuring bars along slowly, checking each move for straightness and other deviations. It took 2 years, working on and off, but in the end they'd measured a line 41,640 feet long, plus a little bit extra. When measured again in the 1960s using a tellurimeter, a radio frequency distance meter, and a geodimeter, a laser-based measuring device, the line was found to be only out by an inch, which you have to agree, pretty impressive for the time they were working in. The start, middle and the end of this line are marked by what look like very odd round structures. You might see one of these if you're getting the train to Derry and you're just leaving Bellarina station. Now that the baseline has been accurately measured, how do you improve the science of trigonometry? Well, that's where Thomas Drummond comes in. He had, along with scientist Goldsworthy Gurney, what a great name, developed a device called a limelight. Its operation is simple. You make a flame by mixing hydrogen and oxygen, point it at a block of lime, and what you end up with is a phenomenally bright white light. If you house all this in a device with a focusing lens, it can be made visible for miles, especially at night. So the limelight was carried up mountains at night to allow mountaintop triangulations to take place. It was said to be visible for up to 70 miles, so there is no doubting the effectiveness of the invention. And that brings us back to the world of showbiz. The limelight was quickly adopted by theatres due to its natural white light, brightness and relative safety. The limelight was a lot more controllable than the gas and candlelight spotlights that had been used previously and was considered a lot safer. So the next time you see someone performing in a spotlight, think back to the early 19th century when a load of surveyors were climbing up Irish mountains with a load of surveying equipment and a limelight, developing the science of mapmaking.